So, hi everyone. While I'm trying to plug this in, I'd like to acknowledge the fact that this is the first talk and it's the first time for me that I am, that's too far into the presentation. Okay. It's the first time that I'm giving the actual first talk, and I'm well aware that most of you probably think about inline documentation. Yeah, that's a chore. That's something I probably have to do. I know I should do it. I know I should document stuff. So my talk is titled InchJS, How to Get People Excited About Inline Docs. But because I knew that it's a bit of pressure, I thought about changing it to how to get people excited about boring stuff. In the next 30 minutes, I'd like to show you how my personal need for better inline documentation led to the creation of software that lets you evaluate your code's documentation and also show you places where your code base could benefit from some love, from some additional comments. And I will also show you a complementary CI service on the web, which today excites hundreds of JavaScript ninjas around the globe. So in the end, you can be the judge whether or not this title would have been more appropriate. So first, a little bit about myself. My name is Rene, and that's also my nickname on most of the social media, most notably the Twitter and the GitHub. I spell it with a triple R in the beginning, which is easy to remember if you try to speak it out loud in pirate voice 3 times in a row. Like most people here, I am a coder by trade, and I have been for the last 15 years. I work at Neopoly, which does not make coffee, like some of you assume, but we are the coffee sponsor. What we do is we realize online games for customers, and these games have a lot of variety just like our customers do. For example, we make multiplayer card games for Panini, where people can collect these Panini cards in real life and then later compete with their friends online on this thing from the comfort of their couch. We also make the corresponding sticker albums for companies like Coca-Cola, which integrate into marketing campaigns surrounding large events like a movie release or currently the European Football Cup. And we make fantasy sports games for media titans like Univision in the United States or the German Bundesliga. If this proposition sounds anything like interesting to you, you can always talk to me or visit us on the interwebs, because like everybody else, we are hiring. So, I've been teaching at the university on the side for the last 2 years, so I would like to start this by clarifying what I mean when I'm talking about inline docs, just so that we're all on the same page. Inline docs are comments of any structure which are preceding a function, module, or class that describe the functionality provided by the documented code fragment. In this case, we just wrote our future self a note that he or she should do the work of actually writing some documentation. As a side note, it's also important to realize what is not considered inline docs. That is any documentation outside of our code, like project websites, FAQ pages, wikis, and readmes. Also very useful, but not inline documentation. Let's use a real example here. So we have a function called hash that seems to return the hash of a file or blob of data, and that also takes an ambiguous second parameter called mode. Now, like many things in our industry, inline docs come in many different forms, shapes, and sizes, and I'd like to go over the most popular ones. This I would call free-form documentation, where you just write some comments in plain English. We also have JSDoc, which was derived from JavaDoc, which is a much more structured way of writing documentation. Like before, we have a comment describing what the method does. We have an example that's tagged with an example tag. We document both parameters, but now we also document the potential return types. And like JavaDoc, JSDoc can be compiled into beautiful HTML documentation. But some people think this is not very human readable. which is why Tom Preston Werner, who also founded GitHub, invented TomDoc. This is a format to be easily readable in the source itself. This has all the benefits that JSDoc has, and we even have one thing that's additional, which you probably see at the top, the public : you have a visibility qualifier. So you have the ability to say, okay, this method is technically public, I export it in a module, but I want to somehow say this is part of a private API and you should not use it outside the project. So much for the introductory class in inline docs, but why do I care about this stuff? How did that happen? Well, 2 years ago I had to document a code base for a university project. I wrote that code, 5,000 to 10,000 lines, all by myself, and like always, I never wrote any inline documentation. And faced with a decision whether or not to put in the work to document this code base, I was confronted with two different views on the subject. The first one is good code is its own documentation. Tests are all my documentation. And this view I held in my early 20s when I was still convinced that when I write code, it's basically golden truths flowing into the keyboard. And everybody who is a decent programmer would immediately understand what I was trying to convey. But the other, a bit more real-life compatible view is the truth that people are simply not JavaScript parsers. In any medium-sized project that is solving a non-trivial problem, a comment here and there, just 1 or 2 sentences in plain English, go a long way of onboarding new developers or helping yourself with your own code a year down the line. So this does not mean document all the things. It just means that explaining why a smart container or an abstract class was introduced with 1 or 2 sentences, or clarifying why a certain part of the API is structured the way it is, really goes a long way. So I decided to document my university project. And I naturally looked for tools to help me with the task at hand, because there must be tools, right? I mean, in all the languages we use, we have tools like ESLint or Rubocop in Ruby, and there are even CI services for code coverage and penetration analysis, and heck, even mutation testing is a thing. But unfortunately, the only tools I found fell into one of 2 categories. The first kind of tool was just looking for the mere existence of a code comment. So in my case, it would tell me that there are 0 lines of documentation, to which I would think, oh yes, I know, I did not write them. And then there were tools tailored towards a specific documentation format, like JSDoc, and they would basically use a checklist and look if you did the things that JSDoc provides, like having documented all the parameters, the return value, given a usage example. But this would lead to the peculiar behavior that you would get something like 65.7% documented in a relatively good and well-documented code base, just because you did not employ every trick in the book for every function. My problem with this was that these tools were just telling me the facts. But I did not want these kinds of facts. What I wanted were opinionated hints where to start. I wanted the software to tell me what to do next. I wanted the software to prioritize for me. And it rubbed me that all the tools are either just looking for the pure existence of a documentation string, or were tailored towards a specific format of documentation. I wanted the software to be independent of documentation format. So what I would like to do for the rest of this talk is take you on a journey through the design process of creating that software, of designing Inch. Let's create a more opinionated tool, a command line interface that tells us what to do, what to document next. So how do we start? Well, first let's make up some rules, because if you want to prioritize things, we need to decide which things are more important than others. So we need a set of arbitrary rules to determine just that. When I talk about rules, I mean something like it is more important to document longer functions than shorter ones. This does neither mean that long functions are a good thing or that short functions do not need to be documented. It's about relativity. If a function is longer in lines, maybe it's more important to look if there is documentation present. If you have a function with many parameters, it's probably more important to document that than a function that does not take any parameters. And it is possibly more important to document modules exporting functions rather than modules just exporting properties. I think you get the point of what I'm trying to convey. With these rules, you can then determine a priority for each code object. These priority can be simple numerical values with higher numbers indicating a higher priority. So we generate a list of all these code objects and order that list by priority value. And what you see here are all the priority values we found during an example analysis. The gray bars next to the numbers show how many issues there are for each priority. And as you can see, all these priorities are hovering around 0. So what we can do is we can cut this list to decide which objects are important enough to document. For example, all with a priority greater or equal 0. And the beauty of this concept is that if we have a function that's tagged as private and that would not show up in our beautiful HTML documentation, is not explicitly excluded here. It's just, it won't show up because it falls under the red line. They are just below 0, these objects. And if we would look at the complete report, we would see them. And for these gray ones under the dotted line, we would also see that a private function with many parameters is still a bit higher than a private function without any parameters. So our rules allow us to assign a priority to every code object in our code base. And I hope you can read that. Here is a short summary of what these code objects are. They are basically just functions and parameters. And in the next step, we have to now look at each individual code object to somehow assess how much documentation there is. And there, for this task, we want to assign a score based on our findings. These scores will range between 0 and 100, where a completely undocumented object will get the score 0, and the maximum score is 100. But of course, there's a catch, because not all code objects are created equal. Take a look at the following example. Here we have a function that is obviously a callback taking 2 parameters. The first parameter is username, and the second parameter we just put an underscore, which is a convention to say I don't care about these parameters because in this example it's a callback and I'm only interested in the username. So our tool should not complain for the second parameter underscore for being documented. So we now get a score which says how complete the docs are and a priority which tells us if this actually matters. And we would get probably a score of about 90 because we did not document the parameter username. With this we can finally get going. But I did have one last thing that I would like to do because I don't like the usage of numbers for this. See, the problem is nobody sees this 90 in warm fuzzy green. Everybody sees it like this. I did not get the high score. I want to reach the 100. I want to put my initials in. So what can we do about that behavior? Inch's solution to this problem is to use grades instead of numbers. So with 90 out of 100, you will get an A. And of course, these grades are just representing intervals of scores. They are nothing more than buckets. But together with the arrow for the priority, they are quite effective at telling you, you did good. Now go on and document the next thing. These code objects are all graded A, B, C, and U. A means it's really good. Inch can't complain about anything. B means we found proper documentation. C is the one that only comes up if Inch thinks something is wrong. For example, you have a typo in a parameter description in the documentation. And the last grade you probably also can't read, but that's a good thing because it's important to note that undocumented objects are not necessarily bad. They are not assigned a red F because it's up to the programmer to decide whether or not he wants to document something that's not documented yet. And Inch will never demand for all code to be documented. So now we have all the ingredients to finally implement the de facto command line interface. Let me first show you how it would have looked if we used numbers for scoring and numbers for the priorities. We would have 3 sections, properly documented, please take a look, and undocumented. On the left is the score, the 50, the 37, the 25. Next comes the priority, the 4s and the 2, and then the name of the code object. But let's have a look how this picture changes as soon as we substitute the score for grades and the priority values for arrows. It becomes much more human readable and inviting. It looks encouraging compared to the slide before. Finally, let's look at the finished CLI and the features it provides. We are now looking at the output of InchSuggest for Node SAS. InchSuggest is also the default command when you just type inch. We see the sections for each grade like before. Please note that A's are missing from the suggest report because as soon as you hit an A, it is no longer included in the suggestions. Below the grade section, there is a list of files to look at. And the last and most important part is that we show a bar chart instead of an overall grade, because showing the distribution paints a more detailed picture than the average grade ever could. Suggest does not include all code objects because it prioritizes for you, but you can show all code objects with inch list. You can see that we now see the A's, the B's, and the U's, and all the objects which Inch found. And finally, we can have a look at any object from that report by simply putting the name of the function into the command inch show and then the object name, and this will tell us what we can do to improve the code object in question. So in this case, we have something that got a B, and this report tells us, well, if you really want to get an A, you can add a code example. So we now have an intuitive, accessible, and gorgeous-looking CLI. But a dirty little secret of our profession is that not everybody who can code and not even everybody who is employed to write code is also a console aficionado. At this point, my problem was that I really wanted to reach people with this tool. But how do we reach people that do not live in a TTY all day? How do we get them excited about this tool? And to answer this question, I sat back and thought, what would a startup do at this point? And the answer is badges. And it's obvious why this is a great idea. People know the concept because it was pioneered by services like Travis and CodeClimate. And if we can get people to put some kind of documentation badge in their README, others will find it there, and we can raise the visibility of inline documentation. So I designed a badge, and this is what it looks like. It is visually very different from the other badges that you find on GitHub. Like in the CLI, there are no numbers here. Instead of that, we have a color bar that looks a bit like a progress bar. And each of the colors works out to one of the grades that we saw earlier. And it's no coincidence that A and B are looking very similar, because we want people to feel good about either one. It means, after all, that at least proper documentation was found. And it's also no coincidence that the undocumented part is very low contrast to the background of the badge, because it is okay to have undocumented parts in your project. And the badge, just like the command line interface, should not judge you for that. These badges are provided by a CI service called InchCI. It provides continuous integration for this documentation analysis, and it's basically what you would expect from a modern CI service. We have GitHub sign-in, you can sync your GitHub repos, and you can install GitHub hooks, webhooks, so the documentation analysis runs automatically every time you push new code. The site can then display reports. Here is the one from Node.sas, which was also one of the first projects on InchCI for JavaScript. And it displays all the information that the CLI version does, including the grade distribution in form of this progress bar thingy, and a list of all objects, now also including direct links to GitHub. So when you click on any of the names, it expands and shows you what the documentation is, and you have a link right there to jump to your repo and look at the actual source code. So it says you could add, you forgot to document some parameter, and you will say, what? And then you can click and see, oh yeah, that's actually what happened. We also have different badge styles, which were pioneered by Shields.io. So we have the plastic style, the flat rounded, and flat squared style. And we also have a build history, which shows you how the analysis changed over time. And this is something that the CLI can't provide. So this is a diff view in form of a newsfeed. So you can see when things get better and when things get worse in terms of documentation coverage. Now, why would you want to use this badge in your project? Putting this badge in your project's README has two benefits. People who display these badges show that they value documentation. And this, in turn, appeals to potential contributors to include documentation when they send pull requests with new features. And it also encourages newcomers to actually read your source code, because they can expect a certain level of hand-holding when they see, oh, there's some documentation present. And last but not least, the overall benefit is, of course, that we raise the visibility of inline documentation, which is something that's normally tucked away very deep in our source code, and when we can display that that is available. So my theory with these badges was that once enough popular projects on GitHub would use them, then some sort of virality effect would kick in. And to my surprise, it actually worked. So today we have 2,100 READMEs sporting these badges on GitHub, not counting forked repos, of course. And the badge is currently available for Ruby, JavaScript, and Elixir projects. And if your second favorite language besides JavaScript is not on this list, don't hesitate to send a pull request, because all of this, the command line tool, the website, the worker infrastructure, and the CI service, it's all open source and available on GitHub. So this leads me to the final section of my talk, the things I learned during the creation of this project. The first thing is, software is about people and solving people's problems. Because I showed you that we already had tools which did a great job at analyzing facts, but they did not solve my problem. And in open source, where there is no money involved, I think usefulness is the currency of projects. And if the usefulness of your software can stand on its own, then that's the chance for the project to matter in the long term. The takeaway number 2 is be passionate about your ideas, because if you are not, nobody else will be. There are 2 important rules in open source which are reminiscent of the 2 rules of Fight Club. Rule number 1, you can't do it alone. Rule number 2, you have to do it alone. Because you can't do it alone because you need users and contributors and people filing bug records and giving feedback. But as everyone here maintaining a project knows, nobody is throwing themselves at you to fulfill your particular vision for your project. And so it's always you who is stealing away 1 or 2 hours from sleep and weekends and family time to get that bug fixed and to get that next release out of the door. And this is simply too hard if you're not passionate about what you're doing. And the last takeaway should be brave enough to build your own tools. If it doesn't exist, that does not necessarily mean that the problem is too hard or your idea, your creative spark is just a stupid pipe dream. More often than not, it just means that nobody has done it yet. So you should be brave. And you should also be willing to fail in the open. For example, Inch for JavaScript still lacks proper ES6 support, but it proves the larger concept. And now we can improve ES6 support altogether. And this marks the end of my talk.